All right, so today we're going to be looking at how to add or subtract when we have like denominators and when we have unlike denominators. So on the first problem, we've got A over C plus B over C. If we have a common denominator, all we have to do is add the values in the numerator and keep the denominator the same. If we're subtracting and we have like denominators, we just keep the denominator the same and we subtract the numerator. For example, if we have 4/5 minus 1/5, what's the answer to that? Everyone? 3/5, right. The denominator stays the same, subtract the numerator. On the next problem, we're looking at if we have variables, what happens? Well, if we have 3x minus 8x and we have the common denominator, it's going to be negative 5x over 2. Then we should always check and see if we can do any simplifying. And we can't, so this is going to be the expression that's the answer. All right, now what about if we have different denominators or unlike denominators? Well, now it's saying to let A, B, and C and D be expressions with C not equal to 0 and D not equal to 0. So if I'm trying to add these two expressions, but they have different denominators, the common denominator here, if I have C and D, is going to be CD. So if that's going to be my denominator, CD, this term is missing a D. So I multiply by D over D. This term is missing the C, so I multiply by C over C. So now I'd have AD over CD plus BC over CD, and then we could just add them. The same thing holds true with subtraction. So let's look at this. What's the common denominator if we have 3 and 2? 6. So I'm going to have to multiply by whatever's going to give me 6. So on the first term, I'm missing a 2. 3 times 2 is 6. So I have to multiply the numerator by 2 and the denominator by 2. So when I do that, I'm going to get 6x plus 4y. Now the second term, in order to get 6, I'm going to have to multiply the numerator by 3 and the denominator by 3. And I'm going to get 6x minus 3y. I have to be careful to look that I'm subtracting. When I'm subtracting, I'm doing 6x minus 6x. What's that going to be? 0, right? Then I have 4y minus negative 3y. What's that going to be? 7y. So we're going to have 7y over 6. We check to see if we can do any simplifying, and we cannot. So that's our answer. All right, easy problem here. We have common denominator, so that denominator is just going to stay as x minus 7. In the numerator, we're going to have 2x squared minus 14x. These are not like terms, so I can't do anything else with them. However, what if I factor out a 2x? What would I have left? X minus 7. In the denominator, I also have x minus 7. So these x minus 7s would cancel. So I would now say my answer is 2x. That's the answer. However, what is the restriction going to be? Good, KK. X cannot equal 7. So this right here is the same thing as that, except for when x is 7. This one is undefined when x is 7. This one is 14 when x is 7. All right, let's look at the next one. We're trying to get a common denominator. What's the common denominator going to be? It's not 10x squared, guys. It's just what? Just 10x. The reason for that is because 2x goes into 10x evenly and 5x goes into 10x evenly. We don't always have to multiply them. Here's the way it works. The factors of 2x are 2 and x. The factors of 5 are 5 and x. They have an x in common, so I have to use an x. I have a 2 and I have a 5. So I can just use 10x. If they have something in common, I don't use it twice. I just use it once. Okay? So 2x has to get multiplied by 5, and so does the numerator, so I'm going to have 15. This has to get multiplied by 2, so I'm going to have 22. And just adding those, 37 over 10x is the answer. There's no restriction. If I asked for the domain, you would have to say x can't equal 0, but I didn't ask for the domain. There's no restriction, nothing canceled out. Okay? All right. I want you to think of this simpler problem. If I gave you 5 6 plus 7 8, what would the common denominator be? 24, not 48. We're trying to find the least common denominator. So if you guys are saying that the common denominator is 24, here's how that works. Factor 6, 3 times 2. Factor 8, 2 times 2 times 2. So because they have a 2 in common, I'm going to use a 2, and those 2's are gone. But I also have to use the 3, and I'm going to have to use a 2 and another 2. 2 times 3 is 6, times 2 is 12, times 2 is 24. That's how we get the least common denominator. If they have a factor in common, it's used once. I have to use this factor, I have to use this factor, and this factor. But I don't have to use 4 2's. I only have to use 3 2's because one of them is common to each. Okay? And then you would know how to go from there. So if I'm trying to find the least common denominator here, I factor this. X plus 2 times x plus 3. I factor this. X minus 6 times x plus 3. What is the factor they have in common? So I have to use x plus 3 once. Now it's gone. Now I'm going to have to use x plus 2, and I'm going to have to use x minus 6. That would be the least common denominator. So factor it completely, do the complete factorization. Then you're going to use common factors once. Add in all other factors. So do the complete factorization, use common factors only once, add in all the other factors. Let's do this one. We have 9x cubed, 3x squared, minus 21x. The factors of 9 are going to be 3 and 3, x, x, and x. That's the complete factorization of this. This factorization, I can factor out a 3x, and I'm left with x minus 7. What do they have in common? What do they have in common, guys? 3 and x, right? So I get rid of a 3, I get rid of an x, I get rid of a 3, I get rid of an x. But now I have to add in all my other factors. So what else am I going to have to add in? I have to use this 3, right? So I have to use another 3, and how many more x's? I have to have x squared, right? And then an x minus 7. So this common denominator, least common denominator, is 3 times 3, which is 9x cubed, times x minus 7. That's the best way to find that least common denominator. If you don't find the least common denominator, after you do your work, you're going to have to keep simplifying. All right, let's try a problem now. This is already factored. It's x minus 2. This is already factored. It's x plus 8. Do they have any common factor? No. So my common denominator is going to be x minus 2 times x plus 8 for both of the terms. So which factor is this one missing? x plus 8, right? So I have to multiply by x plus 8 on top and x plus 8 on bottom. So for this first one then, I'm going to have 15x plus 120. For this term, I'm missing x minus 2, so I have to multiply the top and bottom by x minus 2. Distribute it out, and I have 3x minus 6. I have a common denominator, so now I can combine the numerator. 15x plus 3x is 18x. 120 minus 6 is 114. Then I have x minus 2 and x plus 8. I want to see if maybe 114 can be divided by 18. I don't think so, but no. 114 can be divided by 2. 114 can be divided by 6. 19. Okay, so I could factor a 6 out of the top if I wanted. 18 divided by 6 is going to be 3x. 114 divided by 6. Watch how I do this, guys. 11 divided by 6 is going to be 1 with 5 left over. 54 divided by 6 is 9. So we just want to have it in completely factored form. That's the way the big ideas will ask for your answers, in factored form. So you got to take out the GCF of 6 here. This would be our final answer. There's nothing that we can cancel. Any questions so far? All right, let's look at the next one. First term, just a factor of x minus 7. Second term, a factor of x plus 1. Third term, we have to factor it. How does it factor? Good. X minus 7 and x plus 1. So our common denominator, I have to say, well, what is it that this has in common with this? X minus 7. And then what do these have in common? X plus 1. I only need to use each one of those once. And that's going to be the common denominator, the least common denominator. All right, so what am I going to multiply the first term by? X plus 1. So I'm going to have x squared plus x. What am I going to multiply the second term by? X minus 7. Now watch, guys, it's also subtraction. Here's what I like to do, make it plus a negative. I think it's easier to work with. So now I'm going to have plus, but I'm going to have negative 2x plus 14, because I have to do negative 2 times x, negative 2 times negative 7. I'll do the same thing here, make this plus, and this is now negative. We can either multiply that negative by the top or the bottom. Top makes more sense. Do I need to multiply this one by anything? Nope. So it's just going to be plus negative 8x. All right, combine the numerator. I'm going to have x squared. 1x minus 2x is negative 1. Minus 8 is negative 9x. And then plus 14. All over that common denominator. Does this factor? Are there numbers that multiply to be 14 and add to be 9? What are they? So it's going to be x minus 7 and x minus 2 all over x minus 7 and x plus 1. So these are going to cancel. So is my answer just x minus 2 over x plus 1? What do I have to put, KK? Very good. So this is exactly the same thing as this for any x I plug in except for 7. If I plug in 7 here, I get a nice answer of 5 over 8. But if I plug in 7 here, it's undefined. So big difference. All right, guys, let's keep going. This one, terms already factored. This one factors down into 2x plus 1 and x minus 3. Does that work? Yeah, negative 6 plus 1. Yep, that's it. All right, so our common denominator then, you guys getting the hang of this? 2x plus 1 times x minus 3. 2x plus 1 times x minus 3. What's the first term get multiplied by? Good. So we're going to have 3x squared minus 9x. The next one isn't going to get multiplied by anything. So we've got 3x squared minus 9x plus 10. I got to check this. Are there numbers that will multiply to be 30 and add to be 9? Multiply to be 30 and add to be 9. Multiply to be 30, 10 and 3, 6 and 5, 2 and 15. I don't think it'll work, will it? Let's see, 30, 10, 3, 5 and 2. So my only options would be 6 and 5. Those don't add to be 9. 15 and 2. Yeah, it can't be factored. So therefore, this is going to be our answer. That surprises me. I thought that would be factorable, but nope. All right, last one. Let's factor this. 2 parentheses x minus 1. This is going to be x minus 3, x minus 1. Anybody know what that common denominator is going to be? I'm going to need an x minus 1. Yep. What else? X minus what? What? Okay, so we're using the x minus 1 because it's in common. What's another factor that we have? X minus 3 is going to have to be in our denominator. And what else? What am I missing? 2. That's going to be our common denominator. These two are common, so I can just use that. But then I have to use this one and I have to use this one. It's subtraction. Now, instead of making it subtraction, what can I do? I can make it to addition if I do what? Yeah, change all these signs. So I'm going to add the opposite. I always do that at the beginning. You're much less likely to make a mistake. So this term is missing x minus 3. We have to multiply these out because we're going to add it to this one. See, this one doesn't have to change at all. This is just going to be plus 2x plus 1. But this one, I have to multiply it out so I can combine like terms. So when I multiply this out, x times x is x squared. The outers are negative 3x. The inners are positive 2x. That's a minus x. 2 times negative 3 is negative 6. Now I have to combine like terms. I'm going to have x squared, then what?
Would it need to be multiplied by 2?
Did I forget that? Yes, I did. Yep, thank you. Yeah, this one has to get multiplied by 2. So this is going to be 4x plus 2. Thank you. All right, so anyway, so now I've got negative 1x plus 4x. So what's that going to be? 3x, and then I'm going to have negative 6 plus 2. What's that going to be? Good. Oh, shoot, that's subtraction. Are there numbers that multiply to be 4 and subtract to be 3? What are they? Multiply to be 4, subtract to be 3. Right. So I'm going to factor it. It's x plus 4, x minus 1. And then I have 2 times x minus 1, x minus 3. These cancel. So is my answer just x plus 4 over 2 times x minus 3? What do I have to put, Allison? And what is it? Just 1, right?
Yes.
That's our answer. Okay? Pretty easy, right? Just adding fractions, the same way you've always added fractions, but now you've got variables in there. All right, that's it for 741.